Okay, continuation of 15.16, and this is parts uh, starting at D. So they asked for the phasor diagram. V sub r has a magnitude of 60 and an angle of 78.3 as shown. This angle is from 0. E is 120 volts with an angle of 20 as shown. And V sub C is a magnitude of 102.3 with a negative 11.7 phase angle as shown. Part E says to verify Kirchhoff's voltage law through the circuit, which is going to be the source voltage equals the sum of the voltage drops. So what I did was I calculated the voltage drop as 63, and this is that to convert from, we have it in polar form here. I want to convert it to rectangular form so we can add it. So it's going to be 63 cosine of the angle here plus J 63 sine of the angle. That's VR. And then VC is 102.3 cosine of its angle plus J 102.3 sine of its angle. Now, E is 120 angle of 20, so what we have here is 120 cosine of 20 plus J times 120 sine of 20. Now when you do manipulation of this sum here, you should end up with this sum here, but we're not going to do that because it requires some sinusoidal, manipulation and things like that, and it's just going to be too much work. So we're going to skip all that math. Part F asks for the average power in a circuit equals I squared R. This is just the magnitude of I. That we figured that out right here. And we don't worry about the phase angle, so it's just like it would be in a DC circuit. It's I squared R 3.5 times squared times 18, which is 220.5 watts. And then the final parts where it asks for the power factor. Power factor in this case is going to be the resistance divided by the total impedance, the magnitude. We found that to be 34.26 here. So you take 18 divided by 30.26, you get 0.525, and it's leading because it is a capacitive circuit. The other way that you know it's leading is that the magnitude of the phase angle of I is 78.30 and E is only 20. So I is greater than 20, which means the current leads the voltage. So that's why I put leading here. And then part H asks for the sinusoids of the current and the two voltages of the elements. So we take the magnitude 3.5 times the square root of 2 sine of omega, which is 2 pi f t, 2 pi 60 t plus the phase angle of the current, which is here. And then V sub r, same thing. You're going to take the magnitude of VR as in vector form times the square root of 2 sine of 2 pi 60, which ends up being 377 t plus 78.30 degrees. And then V sub c, its magnitude is 102.3 times the square root of 2 sine of 377 minus 11.70 degrees I got from here. So those are the three sinusoids. I would multiply this out, not leave it this way, but give an actual number for this instead of a radical 2 like it is.